Good afternoon or good morning if you're over on the West Coast. This is Victoria Beal with the Ohio LTAP Center, and I'm so pleased to be able to welcome you to today's webinar. We have had a couple of technical issues with the audio connection, so hopefully that isn't going to continue, but both Bruce and I are working from our phones to provide you the audio today. And hopefully you're able to access the presentation that is on the screen now. I just put it up for you. I'll be running the presentation, but Bruce will be delivering the content. So if you don't mind, a couple of housekeeping items. First off, I'd like for you to look for the question box. And just like you did on Tuesday, if you could please go ahead and drop me a hi or hello in there, I would appreciate it. And for those who put the comments in about your phone, that's great. I'm glad it's working from your phone. That's good. So I appreciate that. And then the other item I wanted to mention is in the handout section, there is a copy of the handouts for today. It says online materials. If you don't get it to download, though, don't worry. I'll send this out as a link. So you'll be able to access it from an email. I also put in some flyers for a couple of upcoming webinars. There's two new ones we just announced in the last day. If anybody on the call has an interest in intelligent transportation systems, we have it's a one-day course that's being offered as a webinar series that we have that information about that in there. And I also put in a flyer about a 1.5 hour webinar that's going to be provided through Federal Highway via Mark Doctor, who has agreed to present on that topic, and it's on restricted crossing U-turns, the R-cut intersections. That was a request from a participant on an earlier webinar. We were able to get that lined up. So that's all I have. Bruce, are you ready to go?
Yes, I am, Victoria.
Great.
Thank you very
all
much. Now, Tuesday, I went through the introduction of myself, Bruce Drews, and we also then talked about the design of a gravel road or an unpaved roadway. And I also need to take and acknowledge, if you change slides for me, we also need to take and acknowledge David Jones. He's a professor down at the University of California, Davis, also the chair of the Low Volume Roads Committee for the Transportation Research Board. We've worked pretty collaborative on this program, and so I'd like to be sure I acknowledge him greatly. Now, like we were talking about on Tuesday, we talked about the design of that gravel road. Today, we're going to be talking about the materials. We'll talk a little bit about subgrade materials because we see a lot of problems with those subgrade materials getting soft and then making our roadway soft. Also, a lot of the times we might see some of our subgrade materials getting a little bit of frost or moisture in it, which then causes frost heaves, which then creates problems as far as the material becoming soft in the spring and having real soft spots on our roadway. So we'll talk a little bit about that. But primarily what we're going to talk about is that unpaved road material. The impact of that roadway material by the traffic, and also what that material should look like. I asked a question on Tuesday about how many agencies had actual specifications for their unpaved roadway material or the gravel road material, and unfortunately, it didn't sound like a lot of agencies had those specifications. So we're going to talk about why we need those specifications. We're also going to talk about testing. What tests need to be done or conducted on those materials so we make sure that we get the best materials for the price that we're paying, being that on Tuesday also most of you indicated that you purchase most of your materials. Didn't sound like a lot of people crush their own gravel, but we still need to test it. So we'll talk a little bit about that. And we'll talk also a little bit about the maintenance of that gravel road, but primarily the maintenance of it is going to be discussed on next Tuesday, the third program of this four series program. And so hopefully you'll be able to tune into that as well. We can go ahead and change to the, if you go ahead and play the movie for me, Victoria.
Yep, I'm going to get that rolling right now. Hang on, everybody. Here we go.
As we saw in the previous section, there's a lot you can do with a motor grader to improve a gravel road. But if the road has poor surface gravel, your motor grader will be of little help. In fact, about half of all problems on gravel roads are caused by bad gravel. So it's important that you understand what good gravel is. In this section, I'll show you what you need to know. First, each public agency should adopt a surface gravel specification and should use it when it's time to purchase gravel. Speaking of that, let's go to a pit for a first-hand look at what good surface gravel is. Actually, the first thing I want to show you here at the pit area is what good gravel isn't. A common source of problems is using base gravel for gravel surfacing. While they may look similar, they're really quite different. Base gravel on average has about 10% less fines to make it drainable. However, that's part of the problem that causes potholes, rutting, and washboarding on gravel roads. Now here's what we came for. Good surface gravel. It's good surface gravel because it has a good gradation, or in other words, a specified mixture of different sized particles. And ideally, the largest particle is no larger than 3/4 inch in its longest dimension. But it also has sand. See all these little particles? They'll fill in the spaces between the big pieces and help lock the material in place. The third component of good surface gravel is 8 to 15% fines. Fines are the glue that keep the road surface bound together. They also keep the gravel from blowing away, washing away, or being dislodged and thrown by vehicles. Plasticity is a technical term for something that good surface gravel has and other gravels don't. Plasticity means that the material sticks together and it resists falling apart. There was an old test, a field test, in which you simply made a ball out of it. If it remains bound, it's clay. If it doesn't, the fines are silt. But if there's any doubt, you must have it tested. It's almost impossible to find good natural surface gravel occurring naturally in the gravel bank. There it's called pit run, but it should be processed by crushing. By crushing the material, you fracture a portion of the stone. It then has sharp edges, which allows those pieces to interlock or wedge together in the fines. If you use natural rounded stones, they will dislodge much easier under traffic, and that leaves the fines exposed to be washed away by rain or blown away by wind. So at the end of the day, crushed gravel helps you to avoid washboarding, to reduce the amount of material that builds up along the shoulder, and it reduces overall maintenance costs. Pretty good deal, huh? When you bring in fresh gravel to resurface a road, you have to consider its moisture content. If it's too dry, you'll need to add water so it will take shape and compact. But if it's too wet, you'll have to work it with your motor grader so that some of the moisture will evaporate. Okay, let's review the main points about surface gravel. About half of all problems on gravel roads are because of poor gravel, so be sure that you get good surface gravel. Each agency should adopt a surface gravel spec, and base aggregate is not good surface aggregate or surface gravel. You need the right gradation. Ideally, every piece of good surface gravel is smaller than 3/4 inch, and about 8 to 15% of your gravel should be fines. And you want enough clay in the fines for good plasticity. You can't dig good surface gravel out of the ground. It has to be correctly processed by people who know what they're doing. When you get to the work site, you may have to adjust the content to make it work right and hold its shape. After you've reshaped the road and placed fresh gravel, you need to consider dust control. That's what we'll look at in the next section.
Okay, I'm going to resume. Okay, that's that problem. I'm going to resume sharing my screen.
Okay. If you'll go to the aggregate classification map.
Yep, we're there.
Okay. So the narrator in the movie that you just watched is, of course, Ken Scorseth. He was originally the LTAP director in South Dakota. He's retired, but he developed a number of tools, and he was talking about the different types of soils and the need for a good gravel road surface to be a hard aggregate with enough sand and enough binder to hold it all together. And the map that I've got here for you, if you take a look at, there's a lot of different types of aggregate or rock that we crush to take and create that aggregate. And depending upon how hard that rock is, determines how well that material is going to last, and also the load that that material is going to be able to carry. And so when you take a look at it,
Bruce, I'm sorry to interrupt you, but I'm having an issue on mine now with the presentation. So I'm going to look at reopening the file. So if everybody will just hang tight for 1 minute, I'm going to reopen the file and hopefully I'll get it to show again. I apologize. I was trying to adjust the size to make it a little bit bigger on the screen. Okay, I've got the image back now. So we're going to stick with this image size that's on here. And then I will get back. Okay, so we're back to the aggregate classification map. And I will share my screen. And it's showing that you guys are seeing it now. Okay, sorry about that, Bruce. All yours.
No problem. No problem. And before I go into the discussion of the aggregate classification map that I want to do, I'd like to ask a question. What are the two primary factors that affect the service life of a gravel road? Weather, speed of cars, traffic, or washboards?
And I
if you would, in the
question. Yep. So they're answering right now.
Okay.
We'll give them a second to respond here. I can see what percentage has responded, and we're only up to about 20%. If you're not getting your answers to record on the screen, it's because you have it in full screen mode. So just escape out of full screen mode, and then it should put those answers in there for you. And we're not recording how you answer the poll questions. So please just, pick what you feel is the gut answer, and that way we'll keep moving forward with things. We're hoping to get about at least half of you voting. So we're almost there, guys. A lot of people in the chat section, the question section, are saying weather, speed of traffic, and weather. That seems to be a big combination. I'm going to do in the poll section. It looks like our responses so far: 84% weather, 34% speed of traffic, 79% traffic, and 10% washboard. I think I can share these results with everybody. Yeah, I just showed everybody what I shared. So the percentages are pretty close to what I read off. All right, I'll go ahead and close that poll up real quick. Did you want any others right now?
Not right now. I'll have another one here in just a minute or two, but I'd like to take and let's go. So it sounds like most of you understand that one of the big effects to our roadways, of course, is weather. Making sure, like we talked about on Tuesday, we talked about making sure that we had the right crown, which should be a 4% crown so that the water will drain off the surface. But we also have the issue of weather or moisture in our roadway with allowing or having moisture gather along the edge of the roadway or in the ditch and then infiltrating underneath of our road, which then, of course, when you get your cold weather that we normally get in the northern part of the United States, we see a lot of frost, and that water freezes, which then expands that water and expands that gravel surface material. And then when it melts in the springtime, we get a really soft roadway, and we have some major problems and some major issues with that. And we can eliminate some of that issue by taking and making sure that, one, our subgrade material is well drained, that we have a good ditch, that the ditch drains the moisture away from the roadway, and that our surface gravel is a good cohesive type of aggregate, so that the material, the water, instead of seeping down into that subgrade, drains off that roadway, so that we don't get that moisture down into our subgrade, and it makes that roadway last better. Now, some people said the speed of cars, and the speed of cars are actually a little bit of an issue, but the primary issue is also generally the traffic, the size of the vehicles that we have on some of our unpaved roadways, as well as the impact of those vehicles as they travel down that roadway. And that's the reason we want to take and have the best gravel that we're going to take and be able to buy or be able to get for that roadway, so that we can make sure that that roadway is in really good shape and that gravel is going to be able to hold up to it. Now, there's some things about that gravel you need to understand, is that, one, the larger type of stone, if you're buying like a 3/4 inch aggregate, your largest size stone in that 3/4 inch aggregate is going to be right around 3/4 inches in size, and then you're going to have some 1/2 inch aggregate, and then some smaller stuff, and then you'll have some sand in it, and then some binder in it. And you need to have that all in proportion so that that larger stone is able to be bedded into that surface, and then have the sand and the binder holding it in place, but yet that stone is what's actually carrying your load, carries your weight of your vehicles. And so that's the reason it's very important to make sure that that aggregate is strong. It's able to carry that load. So in this aggregate classification map, you take a look at it in Ohio, you have some soft aggregates, you'll have some hard aggregates down along the river, which you probably have quite a number of different gravel sources that are being used commercially down along the river because of the hardness of the aggregate. But the main thing is you need to know what your strength of your aggregate's going to be, so that you can take and plan for those issues, those problems. If you'll change the slide for me. So we need to do what's called a Sieve analysis. We'll take and one of the things I want to ask you right now, though, first is a gravel road material free? True or false? The gravel road material that you use, is it actually free?
I'm putting that poll question up for him real quick, and it looks like my computer's catching up on it just changed to that image of the Sieve analysis, so we'll have that back up again in a second when I close the poll. It just says it's distributing the poll right now, so they'll be able to choose here in a second, true or false. Looks like the technology is just running slow today, guys. I apologize.
Yeah, great. Technology is great when it works right.
Yeah, really.
Yeah.
I hope I didn't set us up for failure here, because I told Bruce before this all started that things had been going too smoothly today. So looks like we're getting responses on the poll, hopefully. And it looks like the majority of them are saying false. Yeah. About half of the people have voted, and even those in the question box are saying false.
Yes. And that's
One person
that's
said
a very
it's
good response.
Yeah. Okay. So I'm going to close it down, and yes, I'll share the results. But as I close it out, 91% of the people chose false, and then 9% chose.
Okay. Thank you.
Mm-hmm.
So when you take a look at, and the reason I asked that question is that I have a number of different entities I work with around the United States, and some of them will say, "Oh, well, we just take and we dig our material out of a bank and we just dump it in our trucks and then haul it out onto the roadway." And so they say, "Well, it's free." But the thing is the second that you touch it with that loader to pick it up and haul it out, you now have money into it. And when you grade it, you have money into it. All those things put money into that material. So it may be a lower cost type of material when you first bring it out onto the roadway. But then you also have to look at how often you have to do maintenance on it, how often you have to work on it. Is it taking and performing the way you want it to, or is it breaking down? And so what I tell agencies is that you need to take, and even that free material, you need to take a look at doing a sieve analysis on that free material. And so what a sieve analysis is generally speaking, some agencies have the ability to do it themselves. Some agencies take and hire it to be done. But by the same token, and it's not very expensive, but what you're doing is you take a sample of your material and you run it through your sieves to find out how much rock do you have and what size is that rock. Now, I'm not sure how many grader operators I have in the group, but all those grader operators know that if your rock size or your maximum aggregate size, you're going to have to take and cut down deep enough to be able to lay back twice the maximum aggregate size to be able to get that material to lay smoothly and get it compacted correctly. And on top of that, you need to be able to mix that material back together. So you need to find out what's your maximum aggregate size, what type of other aggregate is in there. Also take a look at what's your percentage or how much sand is in there. I've seen it happen a number of times where you have a roadway that has a lot of sand in it and you can't get your material to compact, and so it's constantly moving on you and you're chasing it down the roadway. And then the final and most important component is the least that you generally have in your aggregate, and that is your binder. How much binder do you have in it? Stuff that's going to hold that sand together so you can hold that rock together. So I really like to see an agency have a specification for their aggregates. I always say, anything you buy, you should have a specification for and ensure that you're getting what you're paying for. So an aggregate specification is very important. Now, if we go to the next slide, I have some samples of some sieves here, and you take a look at the sieves, and the lower row of sieves are all, there's a 3/4 inch sieve, there's a 1/2 inch sieve. You can see that there's a larger gap between the screens, so that allows that size of rock to drop through that screen. So when you get into your cobble or your rock or your fractured stone, those numbered sieves, those 1/2 inch sieves, those 3/4 inch sieves, that inch sieve, those sieves are going to catch those larger stones and tell you what percentage you have of that and how much passes it. Then what we do is, as we go down through and we get into what they call the numbered sieves, the number 4 sieve, the number 8 sieve, the number 30 sieve, what that means is that in 1 square inch of that screen, if it's a number 30 sieve, there's 30 holes in it. in that 1 inch. So your material is going to be pretty small. And generally speaking, on your number 4 sieve, where you have 4 holes per inch of screen, you're going to have material that's just a little bit smaller than a 1/4 inch passing through it. You'll hang that 1/4 inch material up there on that screen. On the 30 sieve, anything that's smaller will pass through that screen, but that 30 will catch a lot of your sand, your coarse type of sand material, maybe some of your fractured rock when it's real smallly fractured. All those little pieces that are going to take and help lock that stone in place. Then as you go down and you have a 50 screen, a 75 screen, a 100 screen, 150 screen, that's 150 holes per square inch of that screen, which is the smaller screen of the back row of screens. With the last screen usually in the stack being a 200 sieve. That's 200 holes per square inch of that screen, which that's a lot of holes in that screen. But that's what passes through that screen is generally your binder. And when you get that binder to come through that screen, you need to find out, okay, is that binder a clay product? Or in some cases, it could be a organic silt type of product, but generally it's a clay. And what type of a clay and how good of a clay is it? Because that's your material that's going to glue the sand together, that's going to glue the rock together and keep your road holding together and being able to withstand that traffic better. So if we go on down, let's take a look here at the next slide. And this is actually a DOT gradation out of a spec book that I've used to deal with. And you take a look at the specifications. So over here on the left-hand side of the gradation chart, you have the sieve sizes. You know, they have a 2.5 inch sieve, a 2 inch sieve, 1.5 inches, 1 inch, 3/4, 1/2 inch, and a 3/8 inch. Then they get into the number 4 sieve, the number 40 sieve, and the number 200 sieve. Those are all indicator sieves, those 4, 40, and 20. And you take a look at it on, let's take an example, say a subgrade A in that very first column. It talks about there's 100% of the material will pass that 2.5 inch sieve. So you won't have any 2.5 inch material in that. But yet there's some material there that's going to be a 2 inch size because you have a specification of 97 to 100% of that material passing that sieve. So you could have 1 or 2%, 2 inch size stone. So that's pretty good size stone, but 2 inch screen. Then you go down and the next screen specification they have is a 1 inch screen. And you take a look at it and they have 65 to 79% passing that at 1 inch screen. So you're going to have some material that's going to be between a 2 inch screen and a 1 inch screen, which is still pretty good sized material, a little large for what we usually use on our unpaved roadways. But then you keep going on down and here's a 1/2 inch screen and they have 45 to 59% passing that screen. So that means that you could have 55% above that screen and 45% below it. But ideally, you shoot for the middle range of that specification. So as you keep going on down, you can take a look at these screen sizes until you get down to that 200. At the 200, they have 4 to 8% passing that 200 screen. So that's that clay. They're allowing 4 to 8% clay in that aggregate sample, or those really fine particles. Now, the reason this specification has that low of a number in the 200 is because they want it to be free draining. All of these materials are either sub-base that's going to be placed underneath asphalt, or a sub-base that's going to be placed underneath the asphalt itself. And so they want it clean so that when the asphalt cracks and the water comes through the asphalt, it's able to take and drain down to the subgrade and then drain out of the subgrade to get out from underneath that asphalt, so it doesn't degrade the asphalt. But by the same token, the problem that we as agencies that have unpaved roadways have with these specifications, there's not enough binder. You need more binder in it to be able to hold this together. Like Ken was talking about in the movie, you know, the sub-base that most of the state DOTs use is not a suitable material for a gravel road surface. So if we take a look at, so let me ask you another question here. So the best material for an unpaved roadway is base gravel, and I pretty much have already answered that for you. It's false. We don't really, for an unpaved roadway, want to use base gravel. We want to use a material that has good hard aggregate in it, has enough sand to hold it together, and then enough binder. So let's take a look at a couple of gradations there. So here's a set of gradations. These actually came out of a manual that I use for the U.S. Forest Service. And you can take a look at these gradations. And, you know, if you're taking a look at a 3/4 inch base. Now, if you look at the H column, it says 97 to 100% passing the 3/4 inch sieve. So you could possibly have a few 3/4 inch pieces of aggregate in there. But generally speaking, most of your bigger rock are all going to be 1/2 inch in size or maybe 3/8 inch in size. So fairly fine. And from a grader standpoint, you know, that finer material, you know, it allows you to take and get out onto that roadway, cut to the bottom of those potholes, the bottom of those washboards, and be able to remix that material back together, but then lay it out in a smaller depth, so you're able to get a little better compaction with it. And then you go on down that H column, and you have your 3/4 inch or 3/8 inch and your number 4 rock, and then you get down into that 16, and they're talking about 28 to 40%. And that's going to be maybe some fractured rock, but mostly sand. You get down into the 40, and then you have the 16 to 26% passing. You know, that's good. What's going to be caught on that screen is going to be your coarser sands. Your black sands will drop down into your 80, maybe even the 100 screens, hut sizes. But then your 200 is 9 to 14%. Now, what I have seen in years past is if you have a gradation that has a good rock content, a good sand content, and then has about 10, maybe 16% at the utmost of clay, you're going to be able to get that material to pack down. The problem that you have is in some gradations, I had one agency tell me, well, we like to have a 20% 200, someplace between actually an 18 to a 26% in the 200 area. That's a lot of clay. And then in the springtime on their roadways, what you end up seeing is a lot of that clay is all filled with moisture, and it's really sticky. But boy, it sticks those vehicles, and people really complain about that clay. Where if they had a little bit lower content of clay down into that 18%, 16%, someplace right in there, they'd find that they're able to hold that rock together. But generally speaking, you're not going to see in the springtime especially, you're not going to see the road get slick and gummy and cars carrying that material out with it. So, you need to be aware of what your gradation is looking like. Okay, so now let's take and go to the next slide here. So what we like to see in our surface gradation, we want a well-graded material, something that's going to have some good rock in it, have some good strong rock in it, some good sand in it, and then some good binder, and then has a good maximum density. We also need to find out what type of binder do we have in it. You take, for an example, if you have silt and you have a lot of silt in your material, silt generally will take and absorb a lot of moisture, but it doesn't take and hold things together. And then it gives up moisture really quickly. And so it doesn't, a silt type of product will not give you a good binding in your aggregate. You need that clay type of material to take and really get that binding of your materials together. So what I like to be able to see agencies do is test your material. If you think about how much cost you have in your material, the cost of testing it is not that much. And doing a sieve analysis, an LA wear, a plasticity index type of testing is very important. So let's take a look at a couple of examples of those types of activities. So if you go to the next slide, a PI test. A PI is a plasticity index test. And what they do is they actually will come in and they'll shake out your gravel and tell you what your gradation is, how much rock and how much sand and how much 200 you have in it. Then they'll take the 200 out of that material, take and use the little instrument that's over on the left-hand side of the screen, and they add water to it, and then it shakes. They cut the material apart, they put a little water in, measure the amount of water, they cut the material apart, and then it clicks that little cup. And if that material starts to come back together, that means that they've reached the maximum moisture content for that material because it's starting to travel in that material. Then you take that material when it's moist and you roll it out. Now, the rolling out part of this test, I actually do quite often out in the field. I'll take and say, if I'm looking at a new gravel or a new type of material, I'll come in and get a sample of that material, get rid of all the big rocks and a lot of the sand that I can get rid of, and have some of that material in my hand. Then I add a little bit of water to it and just mix that material up and start to see if it sticks to my hand. Like the hand that's in this picture, you can see the material is sticking to the gentleman's hand, and it rolls out into a little pencil-shaped element. And if you can pick that pencil shape up and it won't break, or it doesn't take and segment as you're taking and trying to build it, you probably got a pretty good clay in that product, and it's going to help you hold that product together. Okay. So you want to take and know what type of product you can do. So when you look at this, if you want to take an aggregate, use an aggregate, do a sieve analysis on it, an LA wear on it, a PI test on it, and then take a look at how does it compare and how does it work is very important. And you spend a lot of money on that material to do those types of tests. So when you look at a plasticity index, if you have a low number, if you've had a test done on it and you came up with a plasticity index, if you look at the red letters there on the screen, you have the PI, that's the plasticity index, equals the liquid limits minus the plasticity limit. And that gives you your plasticity index. And so you take a look at that PI, and if you have something that maybe you have some silt, a lot of silt in your 200, you won't see that you have a really good plastic material, and so your number is going to be really low. Now, the other side is true, is if you have a high plasticity and your clay is expansive, you really don't want to use it because it's going to create an issue for you. So you need to know, keep your PIs done in those medium types of numbers, and try and keep them out of the high plasticity and also the low plasticity types of limits. So now what I've told you a few tests that you may need to take and take a look at. So what aggregate testing does your organization currently conduct? You conduct an LA wear, a Sieve gradation, plasticity indexing, cleanliness value, or a fracture type of testing. Which tests do you normally perform in your organization when you're looking at aggregate?
Bruce, I think the screen's still catching up. It just put the survey up for them.
Okay.
But I got it up there if they can vote. We're getting some responses here. That's good. We get up about halfway with our voting, and I'll shut it down and share the results. Okay. I'm going to go ahead and close the poll down, and I will share the results. The results hopefully are shared, and it said that we have no one that chose LA wear. 69% chose the Sieve gradation, 19% chose the plasticity index, 9% chose cleanliness value, and 3% chose fracture. So I'm going to hide that and put the slide back up.
Okay, if you can, once you've hidden that, if you could go to the next slide, that would be fantastic.
We're there.
So like we discussed on Tuesday, most of the jurisdictions that were at the class on Tuesday, on the design of a gravel roadway, indicated that they purchased their gravel. Now, if you're purchasing a gravel, you should have a standard specification for your coarse aggregate, your fine aggregate, your PI, and in Ohio, some of your areas probably have a very difficult time getting a really hard, solid rock, because you look at the map that I had up earlier, and down along the river corridor, you get into some really good hard rock. But by the same token, some of your softer rock, as long as you have the capacity, you want to know what is in that rock, because you get some of the real soft rocks like the shells, some of the other types of soft rock. Your traffic will just beat them, break them up. And then you're going to end up taking and losing it, because as it breaks it up, it's going to create them into fines. And then as the traffic travels down the roadway, they blow them off the roadway. And so you want to take and be able to have that good coarse aggregate. Now, since most of you purchase your material, one of the things that I take and I tell agencies to do, because I've seen it happen a couple of times. I have a friend of mine that teaches up in Missoula, Montana, Steve Monlocks, and he always says, he's a professor in materials, and he always says, trust but verify. Trust your contractor or your supplier that they're going to provide the product that you've asked for, but verify that they're actually giving you that product. And this has happened to me a couple of different times where I actually reached out to a local agency a while back, and I knew that they had hired a contractor to come in and crush a lot of their product. They crushed, well over 100,000 cubic yards of material. The contractor crushed it, stockpiled it, and I asked the county, I said, did they do gradations on your material? And the county said, sure. And I said, can I see a couple copies of them? Well, they printed off a couple of copies of the gradations that the contractor had supplied them. And this was in 2013. When I looked at the gradations, I saw that the gradations were actually completed in 1994. Make sure you're getting the gradations that go with the product that you're buying or the product that you're having manufactured. Because if you don't, it's like baking a cake without a recipe. You're not going to be able to get it to hold together the way that it should. And so making sure that you go through and either have them perform the tests or an independent contract or a testing company perform the tests, or you pull the samples yourself and have them tested. Of course, I like to see the coarse aggregate I have up here. Coarse aggregate test, $72. A fine aggregate test, $72. And generally, you just tell them you want the full coarse and fine aggregate gradation. It's going to be right around $140. A PI with liquid limits, about $105. An abrasion test. Now, the LA abrasion, what they do is they'll take the larger stone that's in the sample. They weigh out a specific weight of stone. Then they put it into a drum with the steel balls, and they roll it for a period of time. And then they reweigh the coarse aggregate again, figuring out how much loss did they have in size. And that's what they determine LA abrasion. And LA abrasion is going to tell you how long is your aggregate going to last in your roadway. So I like to see an LA abrasion test done on your aggregates you're going to use. So let's go ahead and go to the next slide. What this is the maximum density curve. And what an agency can do, you can go out to the internet and type in maximum density curve. You can get a copy of this maximum density curve and then take your sieve analysis, and on the perpendicular portion of the chart, you have the percent passing a specific screen size. And then down on the horizontal axis, you have your screen size. So you go in and you take your percent passing, your number 200, and you put a point in there, your percent passing, your 40, or your screen between that, and you plot your aggregates. Now, the line, the black line that's on the chart, that's at the 45 power or 45 degree angle that should give you the best combination of all the different types of aggregates, the sands, and the clays to get a maximum density for that material. And so the further your gradation goes away from that line, it'll tell you if it's above, you may be a little bit short of that material. If it drops way below that black line, you may have too much of that material, and it's going to cause you some problems. So you want to take and plot that chart to indicate, the specifications. You have a good combination of material. If we can go to the next, I believe it's the next slide. If you have a good combination of material, it's going to hold together real well. So in this chart, you take a look at, aggregate with no fines. You have very little fines. You don't have enough fines to fill in all those blank spots between those rocks. And that's going to make a material that's going to take and ravel real easily. It's not going to hold together. You're not going to be able to compact it, and it's going to take, and as you grade it, it's going to move ahead of you. I actually have an agency here in Idaho that I work with that they quarry all of their aggregate. And so they blast this basalt and then crush it and create their aggregate. But because it's all rock, solid rock, they have very little fines. And they have to create some of their fines by running it through the crusher a little bit more. And then they actually import their clay. They use bentonite. They bring bentonite in train loads and then meter it out into their aggregate as they produce their aggregate and then mix it up. And then they get a really tight bond on their aggregate. So that middle component where your aggregate with sufficient fines for the maximum density, that's part of that maximum density test. Are you going to be able to achieve that density? Because the more dense that you're able to get that material, the longer that roadway is going to hold up to traffic. And that's one of the things that we'll talk about actually on Tuesday, is if you come in and you have a roadway, and when you come in and grade that roadway dry, you're taking and segregating your aggregates, which then creates a lot of dust because all that clay is now loose. And as the cars travel over the roadway, it's going to create more dust on that roadway, and you're going to have a greater problem with those aggregates. So you want to take and make sure that you have that good gradation, you have it compacted, and you've used either water and a roller to do that compaction. So you make sure you get your fines in there. And we'll talk more about that on Tuesday. Any questions on anything I've talked about so far? I forgot to stop and ask for questions.
Actually, there was one question I was holding for you. One of the participants would like to know what the source was for the classification map that you showed early on.
The source,
And if you don't have it on the top of your head, I can always send out an email afterwards.
Yes, and I can pull that source up, but it's readily available off the internet. And I'll have to take and send you that information because I can't remember it. Let's go back for just a second. I can't remember if I listed that source on that. Whoops. No, I did not. But I'll take and send you an email, Victoria, with that information. Okay. So you can share that with the student audience.
I sure will.
Go ahead. Oh, I was thinking is the U.S. Geological Services is who I think I've got it from off of their webpage. But I'll check and verify that and send you that information.
Okay, sounds good. And while you were going over that answer, there was another question that came in. They would like to know, how often should the material source be tested?
Well, that's an interesting question. What I prefer to do is anytime, well, first off, you can segregate your materials just by taking and using your loader and picking up your materials up out of your bank. You need to make sure that as you're picking up your materials, you're digging in and getting not just the edge of the pile, but you need to dig into that material so you take and be sure to get a mix of that material. Or if you're stacking that material, you can segregate it by doing a cone type of stacking, which then allows all the big stuff, all the larger stone to drop down to the outer edge of the pile, and you get all your fines in the middle of the pile. And so you want to make sure that your pile is well mixed. How often do I like to take and see a test? Any time that material is either changing, because I've seen it a couple of times where contractors came in and crushed a pile of material and put the material on top of an old pile of aggregate, which then creates an issue or a problem. Or if I hire somebody to come in and crush the material, I like it sampled and tested every time they crush it. We actually had an issue occur here in Idaho. I was running a testing lab for the Idaho Transportation Department, and at the same time we were crushing out of an Idaho pit. The county came in and had a contractor come in and crush their material for their 3/4 inch gravel road material. Their pit, when the contractor came in, was it's about 30 acres of ground, and it was all covered with about 3 to 4 foot deep sagebrush, and had a small building out on it. When that contractor had finished crushing, all the sagebrush was gone. The building was gone except for the tin. They'd removed the tin off the building and placed it off to the side. But everything else went through the crusher. The logs, the boards, the sagebrush, all that had gone through the crusher. And because the county didn't test the product, I went over and took a look at it and pulled a sample, and they had 3 or 4 inch stone in their 3/4 inch aggregate, because the contractor, his screen was wore out. He had holes in it. And so verifying that information and making sure you're getting the right product. And like I said earlier, trust but verify. Make sure they're making the product you're paying for. You want to receive. It's just like I tell people when my wife sends me to the store to buy a dozen eggs, I open that carton of eggs to make sure that the eggs are all solid, that they're not broken. Make sure you're getting what you're paying for. I've seen it. I've experienced it to where, if I reject a product when I was working on a state project because it didn't meet the state specifications, a lot of the times the organization said, "Oh, that's fine. We'll just take it down to the county." They don't test it. And then you're wasting your money. And so testing your product, making sure you're getting the product that you're supposed to have is very important.
Bruce, we have another question that's come in. Do you
Yes.
have time for that one?
Sure.
Okay. The third question, is there any adverse effect from moisture causing the bentonite to swell? Well,
bentonite is actually It's an expansive clay, and so they have to monitor the bentonite very tightly when they add it into the material, so that they actually only add about 8% by weight to their aggregate, because otherwise their roadway will get soft and spongy if they add too much bentonite to it. And so they add it and mix it right into the pile as they're making the pile, so it's spread evenly through that entire pile. And that's an extreme case. I know Steve has had a couple of cases. Steve Monlock up in Montana has had a couple of cases where they're coring their aggregates, and they used a bentonite clay because it's commercially available. And they're able to get that clay, and then they have to carefully monitor it as it goes into their stockpiles. So, like I said, it's like any other clay. If you get too much of it, it's going to cause you problems in the roadway. Natural occurring clay, generally speaking, like I said, 12 to 16% usually works out pretty well. If you get higher than that, then you get a lot of tracking in the springtime, and you get a lot of complaints because of that material. So if you would, the last slide that I had up was, of course, the one with the aggregates, showed the three columns of characteristics of aggregates. I don't know if the next slide that I'd like to show is the material design slide.
You got it. I clicked it. It should be up there for him in just a second. Thanks, Bruce.
Okay. So the material selection, you want to take, and of course, every part of the United States, like the map that I had up, shows that you have a very different types of materials all over the United States. I know that in areas like Fargo, North Dakota, or you have a lot of real heavy clays. You can get some good aggregates, but you've got to get out away from Fargo, North Dakota a little ways to be able to do that. And every time you're bringing material in from someplace else, of course, that's going to increase the cost. But you want to make sure that you're getting your product that you're paying for. There's a lot of different specifications all over the United States and all over the world. Unfortunately, Ohio, as far as a gravel road specification, and taking a look at the specifications I was provided for the Ohio DOT, their specifications are all for sub-base or aggregates or concretes, which virtually none of them are acceptable for a unpaved roadway. And so hopefully your agencies, or if you don't have a specification, you might check with some of your neighboring agencies and see what they've came up with as far as a specification, because that specification will change depending upon what type of rock you're using, how much sand is in the rock, or how much fines you've got to create, and also how much clay or what type of clay is in it. So those specifications are going to change. So you need to take a look at making sure that specification works the best for your agency or your organization. But I've given you some tools to be able to take a look at that material. As you've had it sampled, use that Power 45 chart to see if you got the right distribution to be able to take and hold that material together. Get the PI so you know what type of clay and how sticky and it can become, so that you can take it. If you get a real high PI, you may have to reduce your PI, your plasticity, or your binder a little bit in your material. Otherwise, you get some of that traveling clay in the springtime. Strength is very important. making sure that your aggregate has the strength to be able to handle the loads. We actually had I was on a scan tour I mentioned back on Tuesday, where we actually went down to Arkansas in the, I think it's the it's the Forest Service, I think it's the White Mountains or White Cliff Mountains there in Arkansas. And the Forest Service had actually taken their road and specifically designed it so that they could take it and they combined bentonite, which is lava rock, with a shell, which is a fairly soft rock, and then treated it with a enzyme that bound all that material together. And the Forest Service engineer estimated that he actually he'd placed his aggregate down in a 10-inch lift, and 30 years later, he still had 2.5 inches of that material left on the roadway. And that was amazing, especially since some of his roadways, he was having 1,000 vehicles a day travel over that roadway. But he had specifically designed it to be able to handle the loads and handle that type of material. And then he actually used a chemical modification to take and hold it together. We all need to be using a mechanical modification, which is compaction. We need to use water to keep our material from being segregated when we're grading it. I know I'll be the first one to tell you there are times, when you need to get in and do a little light grading and you can't get water at that period of time. But unfortunately, you're also taking and segregating your material, creating a problem for yourself. But when you do your spring grading or a heavier grading in the year, you need to get that material wet. Otherwise, you're going to segregate it. And then it's going to come apart on you again. And so we need to come in and use water to take and keep it from segregating, and then use compaction to get it mechanically stabilized. And that will extend your life of that roadway. Now, one of the things that Dave Jones has actually done, like I said, he has gone through and dealt with unpaved roadways all over the world. And he has developed this material design chart. So when you take a look at, weighted clay factor, you want to take and be able to have, between 100 and 365, as a weighted clay factor of how much clay's in that overall material. You want to take a look at the distribution of the particle sizes and look at the maximum size as far as this is, of course, in millimeters. Look at the strength factor. He's actually using the California bearing ratio, the CBR. You can use the LA wear as far as the hardness factor. But you take that information, you take the BLS of the aggregate times the percent passing the number 40, and that gives you the amount of shrinkage product in it. Then you take the percent passing the number 1 sieve minus the percent passing the number 8 sieve times the percent passing the number 4 sieve. Divide that by 100, and that'll actually give you a grading coefficient. How easy is that to grade? By the size and distribution of that product. Then what David has done is he's taken a chart and built up a chart where he has, on the vertical axis, he has his shrinkage product. On the horizontal axis, he has the grading coefficient. Going the wrong way here. So as the shrinkage product increases, it goes up that vertical axis, and then as the increase of the coarseness or the increase of the gap of the material, it goes along the horizontal axis. And by doing these calculations, you can go ahead.
Bruce, we had a quick question. They wanted to know, what does BLS stand for?
Let me go back. The BLS is actually the amount of clay or the product passing the number 200 times the percent passing the number 40. So what it does is it gives you a percentage of the number 40 is your sand type of product, how much material of your sand is in there, and then how much is in your number 200 sieve. Okay, and then you multiply those together, and that gives you your how much shrinkage product you have versus your sand. Does that make sense?
We'll let them respond again in the box and let us know if they have any further questions. Thanks.
Sounds great. Sounds great. So you take that shrinkage product number, and like I said, you know, anywhere from 0 to 365 you could have in that area. Then your grading coefficient generally will be between 0 and 60, and you can actually plot it. And it'll tell you how your material is going to perform. So if you have a product that say you have a product that is very fine and it has no shrinkage product in it. So it'd be down here in the lower left-hand corner where you have 0 shrinkage product, and maybe it's really fine, so it's not going to be able to be graded real well. It's not going to compact and grade real well. That'd be sand. And sand doesn't take and work real well as a gravel roadway. Where if you come up the grading coefficient, you get in between 16 and 34. This is an area that you're going to have some sand in it. You're going to have some rock in it. You know, if you don't have any clay in it, you're going to have corrugations and raveling because there's nothing there to hold that material together. And then if you get up above the 34, you're going to be losing your amount of sand in it. You're going to get into the point to where you're more in the rock area, the gravel area. And and if it doesn't have any clay or any shrinkage product in it, then you're going to take and pretty much have some marbles out there. And it's going to be very difficult to grade. Now, if we go up into the chart above the 100%, 100 on the shrinkage product, you take a look at it, and it's an erodible product if you're between 0 and 16, because you have a lot of clay, a lot of sand, but not much rock. So it's going to be a fairly erodible type of product. So you're going to see little rivulets on your roadway. You're going to see, especially if you're in the upper part of the shrinkage product up towards 365 and a lot of sand, it will get hard as all get out in the middle of the summer. But as soon as you get some moisture or you get a little bit of liquid onto that roadway, it's going to move that clay or move that sand off the roadway or get very slick. Now, in the middle of the box is what they classify as a good product. It has shrinkage product, has some sand in it, has some rock in it. And so you have the combination of all the different products to make it into a good gravel roadway. And then with the last one, which is raveling, You're going to see where you have some shrinkage product, but it's more rock. It's not going to be able to be bound together because there's not enough sand to hold it in place, and it's going to create a problem for you.
So Bruce, one question that came in, they'd like to know, is corrugation the same as washboarding?
Corrugation, yes, it is. Corrugation is actually the same as washboarding, and that would be a roadway that you'd have the washboards in it because you don't have the clay in it to hold the sand and the gravel together.
And there's another question that came in, if you don't mind taking it right now. The person
Sure.
said, I wonder if the importance of fines are also valid in asphalt mixtures and pavement preservation techniques. Are these behaviors also valid for chip seals or slurry seals? Do fines play the same role in other applications such as chip seal?
Well, the chip seal is a little bit off course, but by the same token, it's a very good question, and I'd like to address it real quickly. On chip seals, if you take it, and generally speaking, on a chip seal, you want to take and have a clean aggregate, because if you think about applying that chip seal, you're normally using a chipper, and it has a roll in the bottom of it that takes and brings that material out and puts it down on the roadway. That fine material will take and actually go out and get ahead of the coarser aggregate and keep your coarse aggregate from binding to the oil, especially if you have dust in it. That's the reason, if you look at most state specifications for chip seals, they talk about making sure the aggregate is moist and it's clean, because that dust will take and cover up that oil, and then you'll never get your rock to seat and hold into position. So the gradation of the material for a chip seal, you want a clean, fractured rock that's moist. When you apply it, if you're using a CRS2 or a CRS2R or CRS2P, you want a very clean aggregate, and you want to put that aggregate into that oil as quickly as possible, so that you can get it seated into there. Because if anything you have that's seated less than 60% is going to come loose, and you don't want that loose aggregate with the oil on, because that's what causes a lot of your bleeding. So hopefully that took care of the question. The gradation for a gravel road surface is very different than a gradation for a pavement, an asphalt. You don't want the clay in it, because it's going to keep you from being able to get the asphalt to bind to the sand and the gravel. So it's a very clean product. Same thing with your subgrade material underneath the asphalt. You want it to be a clean product too. You don't want that clay in it, because you want the water to be able to, when you get a crack in the asphalt, you want the water to be able to run down, get underneath that asphalt, and then run out from underneath the asphalt. So it's very specific design for the types of activities that you're going to be doing. And so the gravel road, that's the reason we have so many problems with some of our gravel roads, is we use some of the state specifications for their base product or for their asphalt product, and it doesn't work out. And then we're wasting our money. So taking a look at that. Now, coming back to my mixed design chart here, if you take a look at this good area, we can actually expand that good area by using either mechanical or chemical stabilization. Matter of fact, we can take some of our stabilizers and get clear down into this corrugated area quite a ways, or clear up into the slippery and dusty area by the use of stabilizers. but we'll talk about that next Thursday, a week from today. We'll talk about the stabilizers and how to use the stabilizers. But we can increase that workable area of these aggregates by the use of those stabilizers. So if you're taking, you keep clicking through your slides, there's going to be another slide with the material design that I've broken up the good category, which is I think 2 slides on in. It says good but dusty, and also then really good. Those are the ideal situations. But like I said, if we have a roadway that has a lot of traffic on it, has a good product on it, but a lot of traffic, and we're out there grading it a lot, we may need to take a look at using a stabilizer. And we'll talk more about that on Thursday. Now, here's an example. This is a roadway that has a very median grading coefficient. It's not bad as far as grading, but it doesn't have any real clay in it. It's going to take in gravel and corrugate, or a product that is up there in the number 2 area where it has some clay in it, has a good grading coefficient. That's going to be a fairly good road surface. You're going to be able to compact it and make it, and it's going to hold up for you. And then, of course, if it's up in that number 3 area where it's really high in the clay content, when it rains, it's going to get slippery. And in the summertime, if you put a grader on it, in the summertime when it gets hot and dry, it'll get really hard on the top. But if you run a grader on it, you're going to create a dust bowl. Now, here's an example where a product that we have is in the erosion area. This is a picture of that roadway. You can see where it's taken, and it has a fairly high clay content, has some sand in it. It doesn't have a lot of rock. The material, when it gets wet, it'll actually wash right off the roadway and create problems for your roadway, creating kind of rumble strips right in the roadway because of the washes that are in that roadway. So we're right at we have about 6 more minutes, and I'd like to take and check and see if we have any additional questions on anything I've covered, either Tuesday or today.
Nope, we don't have any additional questions. Did you want to run the last poll? Well, you know what? I had one more poll question in here, but I think you already covered it.
Yes, I did.
Yeah, you did. Okay, we're good.
Yeah.
So, I'm not seeing any other questions. Yeah, so if anyone has any additional questions, they're welcome to put it in the question box. Oh, here we go. So how do we repair the corrugating in the last picture?
The corrugating, this corrugating here, what they actually have had to do is they came in and put it, well, first off, you've got to take and mix some water in, and generally speaking, what they'll do is they'll come in a day before they're going to take and work this roadway, put some water on the roadway. It's going to get a little slick, but by the same token, the way that they repaired this roadway is they graded it up, then they brought in some sand and some gravel, some larger type of gravel, to try to take and mix some of the clay in with it, but then it created that roadway surface that would stiffen up and get really nice and hard for them. This roadway now, it's actually a roadway this road is in Australia, and they've actually now put some aggregate and some sand on it, mixed it together. Then they actually put a stabilizer on it. And generally speaking, I think they grade it twice a year, once in the fall and once in the spring. So a significant change in that roadway has taken place. Okay. Any other questions?
Well, there's no other questions right now. So thank you, Bruce, for pitch hitting here with the technology issues today. I greatly appreciate your flexibility, and thank you to everyone for hanging in there through the technology issues. We were so glad to have you on the webinar today, and we are looking forward to the last 2 sessions, which will be next Tuesday and Thursday. So everybody stay safe, and we will see you then. Thank you.
Yeah, I just wanted to remind everybody that the session on Tuesday is going to be grading, and then the session on Thursday will be the stabilizers. We'll talk about stabilizers. So I very much appreciate everybody and their attention, and also their willingness to work with us through our little issues we had today. Thank you.
Yeah. Thank you. All right, everybody have a good weekend. We'll talk to you Tuesday. Bye-bye.
Bye.